Hello everyone, welcome to the channel Talk Gate. In this video, we'll see one very important and very interesting problem of Turing machine in which I'll tell you that how to convert a unary number into a binary number. This problem of Turing machine is actually very important with respect to your university exams. It is very important with respect to your competitive exams as well. So before designing the Turing machine, let's first try to understand that what is the logic I'll apply in this one and what is a unary number system, what is the binary number system. We'll see all those things first and then we'll come on to the designing part. So if we talk about a unary number system, then in unary number system, we know that all the numbers are represented as only ones. Okay, so like I have 1 in unary, it will be single one, then I have 2 ones, then I have 3 ones, then I have 4 ones, then I have 5 ones, and so on. Okay, so what I'm doing in this one, first one, I got this first one, and then after this first one, what I'm doing, I'm just adding 1 to this one. That means if I add 1 to this one, I'll get 2 ones. Again, if I add 1 to this one, I'll get 3 ones. If I add 1 to this 3, I'll get 4 ones. If I add 1 to this one, I'll get 5 ones, and so on. Okay, so similarly in the binary also, what I'll get, we know that in binary all the numbers are composed of zeros and ones. So 1 in binary will also be 1 only. Okay, so that means 1 in unary, 1 in binary, 1 decimal, all are same. Okay, so first number I'll get as it is only, and then to get my second number in binary, what will I do? I'll just simply add 1 to it. That means I'll add 1 to 1. What will I get? I'll get a 0 here, and 1 will be carried forward it, so I'll get 1 0 here. So that means I'll get 1 0 here. Clear? Now to get my third number in binary, what I'll do, I'll just simply add 1 to it. That means I'll add 1 to 1 0. To this number, I'll just add 1. What will I get? I'll just simply get 1 and then 1 here. That means this is my 3 in binary. Again, to get 4 in binary, what will I do? I'll just simply add 1 to it. That means 1 plus 1 is 0, and then 1 is carried forward. 1 plus 1 again is 0, and then 1. So I got 1 0 0 here. Clear? Now to get again the fifth number in binary, what will I do? I'll just take the previous number and then I'll add 1 to it. That means 0 plus 1 is 1, 0 1. So this is my fifth number in binary. Okay, now if you can observe this one, you can see that when I saw 1, this one, when I added 1 to it, I got 0 here. That means 1 was changed to 0 and 1 was carried forwarded. Clear? Again, if you see 0, that means when I have 0 and I add 1 to it, that means 0 was changed to 1, and this number you can see is again same 1. That means if you see a 0, just change it to 1 and your work is done. But if you are adding 1 to it, that means 1 should be changed to 0 and go on to the left hand side. Okay, like you can see here, we have this one, and when I added 1 to this one, what I got? 1 was changed to 0, and then I went on to the left hand side with a carry in hand. Okay, again I added 1 to this one. Again you can see 1 was changed to 0 and 1 was carried forwarded to the left hand side. I got a 1 here. Similarly, if you see that if you add 1 to this 0, what I did? I just simply changed 0 to 1, and to the left hand side, I don't have anything to do. I'm not changing anything. 0 is 0, 1 is 1. So whenever I see a 1 and add 1 to it, what I'll do? I'll change 1 to 0 and then go on to the left hand side with a carry in hand. But whenever I have 0 and I add 1 to it, I'll just simply change the 0 to 1, and I'll not go on to the left hand side. I'll simply go on to the right hand side. Clear? So what I'll do in this one, I'll take an input tape. In the input tape, I'll just divide it into two halves. First half will be used for the input, second half will be used for the output. In the input, I'll just write this number, any number I can take 5 or 4 or 3, anything, and then I'll read one of the unary, and then I'll go on to the output side. There I will write 1. Clear? So for the first one, I'll just read this one, and then I'll go on to the binary side and I'll just simply write 1 there. Clear? Then I'll again come on to the input side, the unary side. There again I'll read one more 1, and then I'll go on to the binary side and I will add 1 to it. Clear? and 1 will be added. I just now told you that how to add this one. Whenever I have 1 and I add 1, I'll change it to 0, go on to the left hand side. Whenever I have 0, I add 1, I'll change it to 1 and I'll go on to the right hand side because I don't have any carry now in this case. Clear? So this is the logic we'll apply in this one. So let's just see how we design this Turing machine. Okay, let's now take one input tape. So I'm taking an input tape here, and this input tape in the Turing machine can have infinite number of cells. So I'm just dividing this into a number of cells. Okay, and these number of cells can have any number of bees also. So I'm just placing bees here initially. Several bees I can place. Then this is my input side. That means I'll write ones here. So let's take 5 number here. So I'm just taking 5 here. So I've written just 5 ones here, and then I'll again add blanks here. Okay, so this is my input side, and this I'm treating as an output side. I can treat this side also as the output side. That means I can write my output here also. Okay, but I'm writing this side, no problem in this one. Okay, let's design a Turing machine. So logic is very simple. I'll just read this one and I'll change it to X. Why I'll change it to X? Just to show that this one has been processed. So I'll read this one, change it to X, go on to the left hand side because this is my output side. Onto this blank, I'll write 1 because I know that 1 in unary will be 1 in binary also. So I'll read this one, change it to X, come on to the left hand side, read this B, change it to 1, again go on to the right hand side. That means my one cycle is complete, one iteration is complete. Okay, so let's do this way only. So let's take the initial state as Q0, and at Q0 my pointer is currently on to the first one. So what I'm saying, I have to read this one, change it to X. So here I'll take a move. That means if you find a 1, you change it to X and go on to the left hand side, not on the right hand side, because on the left hand side I'm writing my output. Clear? So this one will be changed to X and the pointer will point on to this blank now. Okay, and I know that first I have to write 1 onto the binary side. So therefore I'll just take a state Q1 here, and since I have to start my second iteration again, so therefore I'll again come to the initial state with the move as if you find a B, you change it to 1 and go on to the right hand side. That means this B will be changed to 1 and the pointer will now point on to this X because we have a right move here. That means my one iteration is complete and I am at state Q0 right now with my second iteration to begin. Okay, now what I'm finding a X. Here I have taken a move for 1. I'm not finding a 1 right now, I'm finding a X. So therefore I have to skip this X. So I'll take a self loop here. That means if you find a X, you let it be X only and go on to the right hand side. So this X will be skipped and the pointer will now point on to this 1. Okay, and I'm at state Q0, and the machine knows that whenever you see 1, you change it to X. So 1 will be changed to X and the pointer will point on to the left hand side. That means this 1 will be changed to X and the pointer will now come on to this X now, and we are at state Q1. Now at Q1 I've taken a move for blank, but here right now I'm finding a X here. That means this X has to be skipped by, because I have to come here on this side and add 1 to this one here. Okay, so here I'll take a self loop. That means if you find a X, you let it be X only and go on to the left hand side. So this X will be skipped and the pointer will point on to this 1. Okay, now let's see here. When I added 1 to this one, what I did, I changed this 1 to 0 and went on to the left hand side to write my 1 carry. Clear? That means this 1 should be changed to 0. So here I'll take a move. That means if you find a 1, you change it to 0 and go on to the left hand side. So this 1 will be changed to 0 and the pointer will now point on to this blank. Okay, and I'm at state Q1, and the machine knows that when you see a blank, you change it to 1. Correct? So this B will be changed to 1 and the pointer will point on to this 0, and I am at state Q0 right now. Okay, now at Q0 I have two moves. If you find a X, let it be X. If you find a 1, change it to X. Okay, so what I'm finding a 0 here. That means I just have to skip this one. Why? I need to go on to the right hand side to find my next one. Okay, so here I'll take a move. That means if you find a 0, you let it be 0 only and go on to the right hand side. So this 0 will be skipped and the pointer will come on to this x. Again, you can see we have a move. If you find the x, you let it be x only, move on to the right hand side. So this x will also be skipped, this x will also be skipped, and the pointer will come on to this 1 now. Okay, so if you can see here that we have processed two ones in the unary side, and in the binary side also I have written 1 0, and 1 0 is my 2 only. Correct? So far so good. Whatever we have done is correct till now. Okay, now we are at 1 and we are at state q naught. At q naught, machine knows that if you find a 1, you should change it to x. So I'm finding a 1 here. 1 will be changed to x and the pointer will come on to this x now. Okay, and I'm at state q1. At q1, machine knows that when you find the x, you let it be x only and come on to the left hand side. That means this x will be skipped and the pointer will now point on to this 0 now. Okay, now if you see, when we had 0 and we added 1 to it, what we did, we simply changed this 0 to 1 and then I went on to the right hand side, because on the left hand side I don't have to do anything here. Okay, so what I'll do from here, I'll take a move. That means when you find a 0, you change it to 1 and go on to the right hand side. Okay, so this 0 will be changed to 1 and the pointer will now point on to this x and I'm at state q naught. Okay, so that means we have processed 3 ones and I have written 3 on the output side as well. So far so good. Okay, now I'm at state q naught. At q naught, what I'm finding a x and the machine knows that x should be skipped. So all these x will be skipped and the pointer will now point on to this next one. Okay, and the machine knows that whenever you see 1, you change it to x, go on to the left hand side. So this 1 will be changed to x and the pointer will point on to this previous x now, and I'm at state q1. At q1, machine knows that x should be skipped. So all these x will be skipped and the pointer will point on to this 1 now. Okay, and machine knows that 1 should be made as a 0 and go on to the left hand side. That means I found this one and if I add 1 to it, what I did, I simply changed 1 to 0 and then went on to the left hand side. So this 1 will be changed to 0 and the pointer will point on to this 1 now. Okay, and I'm at state q1 only since it's a self loop. Okay, again machine knows that when you find a 1, change it to 0 and go on to the left hand side. That means I got carry from this side and I came on to this one, again I got a carry. Okay, so I'm adding 1 to it. What will I do? I'll just simply change this 1 to 0 and the pointer will point on to this b now. Okay, and I'm at state q1. Q1 machine knows that whenever you find a b, simply change it to 1. That means I'll use this particular move. If you find a b, change it to 1, go on to the right hand side. That means this b will also be changed to 1 and the pointer will point on to the next 0. So far so good. We have read 4 unary ones here and I have written 1 0 0 here. That means 4 in binary is equal to 4 in unary also. So no problem till now. Okay. Right now I am at 0 and at q naught, machine says that 0 should be skipped. So all these zeros will be skipped. Then it says x should be skipped. So all these x will also be skipped and the pointer will point on to this 1 now. Okay, and now at q naught, machine knows that 1 should be again changed to x. So this 1 will be changed to x and the pointer will come on to this x now, and I'm at state q1. At q1, machine again knows that all these x have to be skipped. So all these x will be skipped and the pointer will come on to this 0 now. Okay, now you see that when I added 1 to this 0, what I got, I simply changed this 0 to 1 and I went on to the right hand side, leaving this 0 1 as it is. Okay, so I'm at state q1. At q1, what I'm finding a 0. This 0 has to be changed to 1. So I'll take this move. That means if you find a 0, change it to 1 and go on to the right hand side. This 0 will be changed to 1 and the pointer will point on to this x now, and I am at state q naught. Okay, now at q naught it says all these x have to be skipped. So all these x will be skipped and the pointer will point on to this blank now. Okay, that means I'm not finding a 1 here. On q naught I have a move for x, I have a move for 0, I have a move for 1 also, but I don't have a move for b. Now what is the meaning of finding a b here? That means all the ones have been processed and I have come to the end of the input side. Clear? That means now my work is complete. Therefore I'll just simply take a move from here. That means if you find a b, you let it be b only and go on to the left hand side. Now why left hand side? Because I just want my pointer to point on to this in output side. Okay, I've written 101 here, that is equivalent to 5 in binary. So I need my pointer onto this 1. Okay, so I'll come on to a new state. Let's say we have q2 and the pointer will now point on to this x now. Now onto the state q2, what will I do? I'll simply skip all the x. That means if you find the x, let it be x only, go on to the left hand side. All these x will be skipped and then my pointer will come on to this 1. That means I have to skip 1 and 0 also. So here only I'll take a move. If you find a 1, let it be 1 only, go on to the left hand side. If you find a 0, let it be 0 only and go on to the left hand side. That means my pointer will skip everything and it will come on to this blank now. Okay, now onto this blank I'll take a right turn and point my pointer here onto this one. So therefore I'll take a move. That means if you find a b, let it be b only, go on to the right hand side, make a state q3 and the pointer will now start pointing on to the output. So this is the Turing machine which acts as a unary to binary converter. I hope this is clear to you now. Thank you so much.